Well, here we are again, another fun, exciting episode of Algebra 2, and we'll be looking at the change of base formula. You're thinking, why do we need to use change of base formula? Well, just about any calculator out there on the market will do log base 10 and log base e. Of course, you won't see log base 10, you'll just see log, right? That's the common logarithm. You won't see log base e, you'll see ln for the natural logarithm. So there's a TI-89 on display, and sure enough, they've got a log button right next to the ln button, and the second features are even 10 to the x and e to the x. Right? We zoom in and say, oh my goodness, look at not only are log and natural log right next to each other, but obviously log is the inverse function for 10 raised to some power, and natural log is the inverse function for e raised to some power. If I use the calculator on my desktop, I might have to make sure that I switch it to scientific mode. If you just bring up your calculator on your computer, at first glance you're like, hey, all I can do is add, subtract, multiply, divide. Now make sure you get in scientific mode. And sure enough, you can do logs, right? Either common log or natural log. Here it is in well, that must have been a TI-84 up I had previously. Sorry, I said TI-89. That must have been a TI-84 I had up previously. Here's the TI-89, which is fantastic if you want to do some calculus. For algebra, not so much. You'll notice that on the keyboard, both natural log and e to the x power are a secondary function, and nowhere on the surface of the calculator can you even find common log, right? Log base 10. I have to actually go into the catalog, and if I go into the catalog, I can then go find common log. Right, so the TI-89, it's assuming you're going to be doing more calculus, you'll be doing more with natural logarithms. You're not going to really touch, common logs. Now, I'm not advertising that you should go with Texas Instruments. Notice I've got a screenshot of a Casio, and indeed the Casio has a log button right next to a natural log button. And then I've got a Hewlett-Packard. Type of calculator I grew up with was Hewlett-Packard. I had a 33E. This, I believe, is a 15C. A little bit more difficult to see, but they do have natural log and log, but they're the secondary functions on the same button as e to the x and 10 to the x. So just about any type of calculator you get your hands on, it'll do log base 10, it'll do log base e. But we want to be able to access all your base. All bases, all bases, all bases, all bases, Okay, I'm actually a little bit too old for when that game came out, but I had a nephew that got that for Christmas the year it came out. It was like a really, really, really exciting game, and I just remember the introduction. We just scratched our heads like, what? And then, of course, it became a huge internet sensation way back around, the year 2000 maybe? I mean, a long time ago. Anyway, we don't have to use base 10 or base E. However, if you have some other base, and you're like, you know what, I want to do base 3 or base 5 or base 7 or whatever, and you say, man, my calculator only does base 10 and base e, we want to be able to rewrite them using the change of base formula, right? So that way I can actually do any logarithm on a calculator, even if the answer comes out to be very, very messy. Okay, and as usual, if you are a base, you got to be a positive number. If you are the value, you've got to be a positive number, right? Because if I've got a positive number base, no matter what exponent I raise it to, the value of that expression has to be positive. Now, the exponent, of course, could be negative, but the base has to be positive. The result after we raise it by an exponent has to be positive. And we don't want the bases to be 1, because if the base is 1, we don't really have an exponential function, right? It's just a constant, because 1 raised to any power is still 1. So if we have log base c of a equal to log base b of a over log base b of c. So I can change anything I want to any base I want. And of course, since my calculator will do base 10 and my calculator will do base e, I'm going to choose and have b either be equal to 10 or e. Either one's going to work fine. Okay, now if all that was gibberish, because sometimes I give the mathematical definition, and the mathematical definition's not too straightforward. Let's take a look at some examples. So, let's pretend I got log base 3 of 14. My calculator won't do log base 3. The exponent table doesn't do me any good, right? 3 squared is 9, too small. 3 to the third is 27, too big. So, let's convert it to base 10. Right? If I just put log, that's log base 10. I don't need to put the little 10 down there. Lazy mathematicians strike again. So I make it log 14 over log 3. On a calculator, I can figure out log 14. On a calculator, I can figure out log 3. And if I do the division, take the answer from log 14, divide it by the answer from log 3, I come up with about 2.4. All right, if I round it off the 2 decimal places, 2.40. Now, if I actually just do it all in one shot, instead of rounding off my answers as I go, I still get about 2.40. But you'll notice when we get about, 5 decimal places deep, it changes a little bit. But it's still going to be about the same thing. 2.40 if I round off the 2 decimal places. Now, let's do an example instead using natural logarithms. Let's use, how about log base 3 of 14, right? My calculator won't do log base 3, but it will do log base e. Of course, I don't write log base e. I put ln for natural log. So I change it to natural log of 14 over natural log of 3. Now, you think we're going to get the same answer, right? Because we can change any base we want. So natural log of 14, that's really different. 2.639, boy, that's really different. Natural log of 3, 1.0986, well, this is real different. Is this working out? Did I make a mistake? Let's divide. Holy cow, when I take the natural log of 14 and divide it by the natural log of 3, I get just about the exact same answer. I'm getting real close to 2.40. Now, it doesn't look totally identical, but again, that's because I rounded off. If I just ask the calculator to straight out do natural log of 14 divided by natural log of 3, I get the exact same result on the calculator that I did when I did log 14 divided by log 3. Right? Those two answers are identical. 2.402173503. So if I just go straight into the calculator and just punch the button straight through and I don't do any rounding until the very, very end, I'm going to have identical results. So you can use log if you want to use log. You can use natural log if you want to use natural log. You'll get the same result. Now, if you're kind of curious, like, is this really working? What is this mumbo jumbo? Let's try to do one that we can do by hand without a calculator. But before we do it by hand, let's use a calculator. And again, I'm going to do this with base 10, so I'll use a common log. I'll do it with base E, I'll use a natural log. But then I'll do it by hand, and we'll see if we get the exact same answer all three ways. Right, so using a common logarithm, this time I'm going to do log base 4 64, because this is one we can do by hand. Now you know the answer is going to be 3, because 4 to the third power is 64. So spoiler alert, we're going to get 3, right? 4 to the third power is 64. Okay, let's push buttons on the calculator. Let's do log 64. Divided by log 4. Oh my goodness, it's exactly 3. What a shocking surprise. Now, of course, log 64 is a weird looking decimal. Log of 4 is a weird looking decimal. But log 64 divided by log 4 is exactly 3. Let's try it with natural logs. Do you think we'll get the same answer? Well, if I have log base 4 is 64, I can convert to base E, so I've got natural log of 64 divided by natural log of 4. And surprise, surprise. Now, notice natural log of 64 is a little bit different than log of 64. And natural log of 4 is different than log of 4. But it's the same ratio. When I take the natural log of 64, divide it by the natural log of 4, we come up with 3. Surprise, surprise, the answer is 3. Now, let's do this by hand. But I'm not going to do 4 to the third power is 64. I'm going to use the change of base formula, and I'm going to change it to base 2. I'm like, okay, I'm starting with log base 4 is 64, but instead of using base 10, or using base E, I'm going to use base 2. Okay, so log base 2 is 64. 2 to some mysterious power 64. That's 6, right? 2 to the 6th power makes 64. Log base 2 of 4. 2 squared is 4. So I've got 6 over 2. And 6 divided by 2, oh my goodness gracious sakes alive. 3! Right? So we actually got that answer 3 4 different methods, right? Because before we even started, I said, hey, 4 to the third power is 64, right? I could have looked at my exponent table and done that one. But if I convert it to base 10 and use the log button on my calculator, I get an answer 3. If I convert to base E and use my natural log button on my calculator, I get 3. I don't care which way you do it. If you like to use log, go ahead and use log. If you like to use natural log, use natural log. If you're wild and crazy and you want to do it by hand, sometimes it's not possible because sometimes you just have a number that doesn't work well with a base. But we can use any base we want. The ratio will be the same. So let's do some examples. Let's evaluate each expression. Oh, hey, you are going to need a calculator. Ba, ba, ba. If you have a handheld calculator, that's fine. Maybe you've got a calculator on your cell phone you want to use. That's fine. Or maybe you're using a laptop, or maybe you're even using a desk computer because you're at home. And if you do want to just use the calculator that's on your laptop, you might need to pause a moment and see if you can make sure that you've got the scientific settings so you can see the log. Also, if you check on Quick Schools, I have put links to 2 different online calculators that I tried, and you'll actually see how I use them later on in this PowerPoint. I actually went and I tried 3 different online calculators, and one of them I just thought was kind of like a pain in the neck to use, and so I thought, nah, I'm not going to share this one. But I put links for 2 of them on the Quick Schools homework tab, or you might be far better at finding a good calculator with Google than I was, or maybe you'll use some sort of search engine besides Google, but I'm sure whatever you end up doing, you might find out something that's better. And so we have some examples coming up. Now again, pause the video if you're not ready, but I want you to try to figure out the answers before I share the answers. Okay, so I'm going to pause here. You got a calculator? You better pause the video if you don't have a calculator. Okay. Everyone have an answer for log base 2, 503? Here comes the answer. 8.97. If that's what you got, congratulations. If you did not get 8.97, this is what I did with a calculator. All right, I decided to just use plain old log. And so log 503 divided by log 2, right? I just used the log button. If you're having a difficult time remembering which number goes on top and which number goes on the bottom, notice how log base 2, that 2 is kind of like a subscript down below. That's the number that goes down below, right? The 503 on top, the 2 on the bottom. And from now on, I'm going to show you calculator screenshots, but I'm not going to bother rewriting it as log base 2 of 503 equals log of 503 over log 2, because, come on, we're just going to grab a calculator, right? So, log base 8 of 3, please get an answer. I'm still waiting. Pause the video if you have to. All right, you can always restart it. Here comes the answer. Weird, it's less than 1. So you can see that I did the same technique as the previous question. I just did log 3 divided by log 8. Oh, 3 is less than 8. So of course the answer is less than 1. Right? If I start out with 8 and I have an exponent like 2 or an exponent like 3, it's going to get big. But if the exponent is less than 1, it gets small. Log base 5, 27. Okay, there's Jeopardy theme. You ready for an answer? Hope you're hitting pause if you're not ready. Here comes an answer. 2.05. Now, I'm still using my TI-84. It's actually an emulator on my laptop. I don't actually have a TI-84 calculator. I just downloaded an emulator for free. Notice this time I did natural log instead of log. Right? It doesn't matter which one I do. I can use either one I want. So sometimes on a calculator you might find one of the buttons is easier to find. So I just did natural log 27 divided by natural log of 5. And it looks like 2.04, but if I look behind the 4, I see a 7, so, better round off correctly. Same thing with the previous question. See, instead of putting 5.2, I put 0.53, because behind that 2 is an 8. Log 4, 64. Okay, I'll pause. Use your calculator. Okay, who's the wise guy? Wasn't this the example we just did a few minutes ago? Yeah, you better get 3. Now, to change pace, this is the scientific calculator that is on my laptop. I made sure I was in scientific setting. This was a pain in the neck to use. It took me a while to figure it out. I had to type in 64, then hit the log button, then divide, then 4, then the log button, and then equals. I didn't find that very user-friendly at all, but that's the one that is just like on my laptop. Log base 9 of 3. Oops, I was quick on the draw there. Hopefully you had the answer already. This makes sense, right? Square root of 9 is 3, and of course square root means an exponent of 1/2. And again, I use that goofy calculator on my laptop. Log 3 divided by log 9, I get 0.5. But again, I could have done that in my head, right? Square root of 9 is 3, so the exponent's 1/2. Okay, make sure you get this next one done before I goof up and reveal the answer. Background music, waiting time, elevator music, Jeopardy theme, blah, blah, blah. All right, ready for the answer? Negative. What have I done? Oh, the answer, that value of 0.5 is less than 1. So if I start out like with a number like 7, 7 to the first power will still give me a 7. An exponent of 0, 7 to the 0 power, that's still positive 1. Right? Well, I got to get all the way down to 0.5. So I need an exponent smaller than 0, right? 7 to the 0 power would be 1. 1 is too big. I want to get all the way down to 0.5. I need an exponent smaller than 0. I switched over to using my TI-89 that I downloaded using WabbitEmu. And I did a natural log this time just for change of pace. Natural log of 0.5 divided by natural log of 7. Calculator says negative 0.0356207. So today am I going to round it off to negative 35 or negative 36? And he said, well, it looks like it's actually closer to negative 0.36. All right. One last example. Get a calculator. Now, this again is one I should be able to do in my head. If I start with a base of 4, what exponent do I use if I want a value of 1? 4 to what power gets me 1? Well, it's got to be 4 to the 0 power. Now, this is where I took a bunch of calculators on the internet for a test drive. Went to 3 different websites that advertise that they have online scientific calculators. And the one that's kind of like the center bottom of the screen, that's a pain in the neck. I mean, if you look at the keyboard, you're like, you don't even see add, subtract, multiply, and divide, right? There's different layers to their keyboard, and I had to dig down far enough to find the keyboard with log. And then for the numbers in the parentheses, I had to use my keyboard. It's like, good grief. Now, the one I'm highlighting here in purple, that was my favorite of the bunch. And that is the first link that I put on Quick Schools. It was pretty straightforward, easy to use. Right, I hit the log button, typed in the 1, and that's divided by, it's probably hard to see with the screenshot, but that's division. And then I hit log, and I hit 4, and hit equals, and there in that blue stripe it says, hey, your answer is 0. Okay, so that's cool. The one I highlighted in yellow, this one worked too. It was straightforward enough, but the website wanted to have me say, okay, you can use cookies. And then if I'm looking there, you'll see there's a log button, but I don't see a natural log button. So I put the link for the one I highlighted in green also, but I prefer the one I highlighted in purple. But again, using a search engine, I don't know, Google, Bing, and then there's some other ones out there that some of you have favorites. Using a search engine, if you really need a free online scientific calculator, you can find one. So, we're going to have a worksheet. Yay! Cause for celebration here. Oh, what a fireworks display. And then, if you complete your friend and mine the worksheet, the IXL today, change of base. And again, anytime we do IXL, sometimes you kind of have to get used to what you're doing. And when you start working in the IXL and you start typing in answers, you'll notice they have a little button you can push if you need a fraction, because for change of base, obviously you're going to want a fraction. But then there's two different buttons you can hit for log. One of them wants you to put the base in, one of them doesn't. Whenever possible, I just used the plain old LOG button that did not have the place for the base, because if you just use plain old LOG, that's log base 10. So unless the directions tell you to use a certain base, I just went with LOG. Or if they tell you to use a common logarithm, remember, common logarithm means base 10, right? So just use the plain old log button. But if they ask you for some other base, you can use the button that allows you to put in whatever base you want. So it might be a little tricky getting used to it, but I think once you get used to it, you'll cruise through IXL. Also, I think you'll cruise through the worksheet quite readily. And so that will take it for today.